Hello everyone, and welcome to Solving Quadratic Equations by using the square root property. Okay, so if we have quadratic equations that just has a variable squared in it, we can solve it by using what we call the square root property. So we want to write the equation in the form of a squared equals b, and then take the square root of each side. Now, when we take the square root of each side, we need to make sure that we consider the positive and negative case of that right-hand side that we take the square root of. And why is that? Well, remember that you can get two answers for a squared equals b. Let's say we have x squared equals 9. We're looking for the numbers that we can replace x with that would equal 9. So if we replace x with 3, that would be 3 squared equals 9, which is true. However, if we replace x with negative 3, that would be negative 3 squared equals 9, which is still true. So we have to consider the positive and negative case there. Okay, so let's look at a few examples. This first one, we have x squared equals 16. So we have the x squared already isolated, equals 16, and you might be able to figure out the answer without doing any algebraic work. However, to solve this, we would take the square root of each side and consider the positive and negative case on that right-hand side. So the square root of x squared is simply x. Now, 16 is a perfect square, so that will give us positive or negative or plus or minus 4. So that gives us two answers. That tells us that x is equal to 4 or x is equal to negative 4. So you can write your answer either way depending on the system that you're using or your instructor. Okay, x squared equals 18. Again, the x squared is isolated, so we want to take the square root of each side and consider the positive negative case. So the square root of x squared is simply x. The square root of 18 is not a perfect square. However, it does have a perfect square factor of 9, so we can rewrite that as 9 times 2. And then take the square root of 9. So x could be equal to positive or negative plus or minus 3 times the square root of 2. Now, you can use the square root property as long as you don't have, in this case, the x to the first power, like x squared plus 2x plus whatever. As long as it's just x squared and a constant, then you can use this. So what about 3x squared minus 30? Well, let's see if we can isolate that x squared term. So let's add 30 to each side. Then we could divide by 3. Now this problem looks similar to the problems that we just worked. We want to get x to the first power, so let's take the square root of each side of the equation. The square root of x squared is simply x. The square root of 10 is not a perfect square and does not have a perfect square factor, so it's just positive square root of 10 and negative square root of 10. Okay, what about x minus 6 in parentheses squared equals 18? Well, we still have that x that's being squared, so we still can use the square root property. As long as we have one side being squared like that, we can use the square root property to get rid of that exponent square. So take the square root of each side, consider the positive negative of that square root of 18. So the square root and the exponent square cancels out. And that gives us positive negative square root of 18 on the right-hand side. Now 18 is not a perfect square, but it does have a perfect square factor. So we can simplify that, write that as the square root of 9 times 2. Take the square root of 9, which is 3. And then finally add 6 to both sides to finish the problem. So our two answers would be 6 plus 3 times the square root of 2 and 6 minus 3 times the square root of 2. Okay, let's take a look at a couple more problems. X squared plus 9 equals 0. Okay, so let's isolate the x squared by subtracting 9 from each side. So that gives us x squared equals negative 9. Now we know that it's not a real number that we can multiply times itself to get negative 9. However, we could have an imaginary number answer. So let's take the square root of each side. The square root of x squared is simply x. Let's change that negative underneath our radical, our square root there, to I squared. Now 9 is a perfect square, and I is a perfect square, so I can take the square root of each one of those. To give me plus or minus 3i. Okay, now our last problem, 3x squared plus 36 equals 0. So let's see if we can isolate that x squared again. So let's start off by moving the 36. Okay, and then divide both sides by 3. So now we have x squared equals negative 12. So again, we want to make that into x, so let's take the square root of each side. Make sure you consider your positive negative case. The square root of x squared is simply x. 12 is not a perfect square, and we have a negative. However, 4, which is a perfect square, goes into 12, so we can rewrite that as 4 times 3. Change that negative to I squared. Now I can take the square root of 4 and the square root of I squared to simplify, which gives me 2i outside of my radical times the square root of 3. Okay, I hope you found the video to be helpful. Thank you.